We're back. Um, yeah, I'm not quite sure what happened there. Something with the streaming software just lost connection, even though my computer still has internet connection. So, um, apologize for that. I think that probably knocked everybody off. So, eh, it happens. But I will at least try to get back to where we were. And I'll just, I'll try to finish it off. It looks like a couple people popped back on, so sorry about that. I really don't know what happened. Just something with the streaming software. I instantly saw it lost connection, and that was that. So restarted. Seems to be okay. It is my first day actually using this particular piece of software, so um, you know that's how it goes. But all right, let's go back. We'll do a full screen on the emulator. All right, so I'll just go again back through, a couple of things I wanted to show as far as demoing. So we were talking about like co-channel interference, but there's probably some other more useful things that I could demonstrate as far as thought process goes. So I think one would be, been talking about it. I think what makes this overall, one of the unique features is the way it handles directional patterns. So if we go back to the use case I was talking about, or the situation between DC and Baltimore and York, you could kind of see it playing out. So let's just pick a location, somewhere around Baltimore here. So if we go down, so this is probably so it is in weak mode. All right. So let me find a spot that actually has we'll see if we could find a DC and Baltimore one. All right, so this is an example here. So what this does, and it could be subtle in certain circumstances, but this we factor in at the angle the FCC makes this data available as far as like at the particular azimuth, how much percentage of their directional pattern they're sending in a certain direction. So, for instance, here we're a little bit southwest of Baltimore here. Kind of right along. Yeah, I guess that's the Baltimore Washington Parkway. I guess this would be, just sort of probably just south of BWI. And so WJZ still puts in a pretty good signal here, but they're only sending, not even 4 kilowatts down that way. The reason is because of DC, Woodbridge here, they're only sending 2.5 kilowatts toward Baltimore. So that gets factored in as far as U.S. stations go, and also Canadian stations in the app, their directional pattern as far as their the percentage that's sent in a particular direction. So that's one of the things you've probably noticed if you've dug around in the app a little bit, but that helps make those predictions much more realistic as far as their particular, if the pattern is pretty sharp. There's probably a few other good cases I could highlight as far as that goes. Even locally here in Jersey, I'll do one like WPST 94.5. They're a 50,000 watt signal, but they only send If we look here, this is over in Monmouth County, Tinton Falls. Because of WJLK and Asbury Park, they're only sending 20 kilowatts, toward the east. JLK an adjacent channel. So that, you could probably find, so many other examples of that kind of scenario. But that's, part of what that the directional pattern data that's out there, that's in the FCC, that is factored in for any directional allocation in the app as far as the US is concerned. So something that I think distinguishes RadioLand. I don't know if there is, again, maybe the FM Fool, maybe the FM Scan applications, but, I don't think any other site factors those patterns in. I could be wrong on that. But I think as far as making accurate predictions, that's something that's pretty vital. So the other things in this dial view, I sort of started to go into it. Like I like the weak mode, I think the best. I think the app defaults to the medium mode. So what are like the cutoffs? What are the thresholds? So local mode is 60 dBu VM. Medium is 50 and weak is 40. Now, it's not just a matter, as far as on the app backend, of limiting to the certain threshold. It also has to do with the amount of stations that are queried, because that affects performance. You'll notice, strong, that was probably about 2 seconds. Weak, let me get the right one. That's been on average 5 or 6, depending on the area. This is a little longer than that. And that populates 89 stations. But it's not just because of the threshold. It's also, there is logic, and Bryce helped with this quite a bit, as far as determining, based on station class, whether or not the station should be evaluated in the query. So that's all factored in as to the response time of the signal threshold, weak versus medium versus local. So just something to keep in mind. As far as setting your location, so that is something that I think is, a very vital part of the app. So you can just, if you want to do it in the form of a search query, you can come here. We use an API that basically has autocomplete. So if you wanted to come in here and, you can certainly just type a town name, and plenty will come up. You can, now it's not, I would not say it is exhaustive as far as actual addresses, but you can certainly do that. If we do 1632, I don't know, Amsterdam Road in Fort Wright, Kentucky, that will, pinpoint, the one thing I would say is, now it doesn't accept coordinate pairs, and that is something that a couple people have brought up. And that I think that would be a really good feature to have. That is something I will try to get in there. But if you can find a specific address, I would definitely, that's at least close to the destination you're trying to match. I would say definitely go for it, because, again, the whole idea of Longley Rice, the whole idea of this app is it's not just a matter of, Philadelphia. I'm just, doing the center of Philadelphia. Well, there could be a lot of differences if, just to use Philadelphia as an example, like up and above the fall line, talking about Roxborough, Germantown, heading that way, versus Penn's Landing, there's a decent elevation difference once you go below the fall line. And there's, probably better examples, West Coast cities, places like that. So be specific with your search. Even though, I think having a text-based search is very important. So that'll like autocomplete for you. You just need to put in at least 4 characters. But what you can also do, and this is a feature I was very excited to be able to put in. So we have the map view, which plots where the stations are as far as like their exact location on the map. This just frequency call letters. Right now we have the class of the station in the flag here, which that's debatable whether or not that is something that is worth keeping. As far as an identifier, I know there's probably better ways to convey the stations, or something. What I wanted to find was something that would convey like the power of the station, that would you'd be able to fit on one of those map markers. And I ended up just settling for the station class, with having some sort of legend built in to talk about those classes. But for the average user, I don't know if that is extremely helpful or not. So I am very much undecided on that. But what you can do here though is with this map view, obviously you're right now we're in the Cincinnati area. Let's say we wanted to go up to Indy and see their dial. You just click and hold, to tap and hold as it would be on your phone. And now, this is using weak mode, so it'll take a few seconds, but we have the Indy dial. And so obviously these little cluster icons expand. The issue that, you obviously run into is a lot of these stations are co-located at tower farms. And so, with this little, and I know it's already 9 o'clock here, but I'll talk about a little bit as far as like the software design. The framework I used has some really cool plugins as far as because obviously I'm using these for radio stations, but what about restaurants? What about fitness clubs? Places like that are very close together. Like, what do you do in those circumstances? And there's this marker cluster package that worked, really well. Now, again, we could probably do these a little differently. Maybe, translating the markers that are shared a little differently. Although I think this is okay. I'd be curious if anybody has any thoughts. And good to see, 7 folks after our little technical snafu come back on. Thank you. Thanks for hanging around. So I think, but getting back to it, what I think is a really cool feature is you just can sort of hop around. If I wasn't using the emulator, I would be able to zoom out. It's a little harder on the emulator to do that, but you can just sort of explore. I think there's a lot of different use cases for this. Obviously, the DX use case definitely is, one of them as far as, distant signal hopping. If you wanted to, if you have a station in a particular area and you want to find others, you can just, drop a pin. But just to get a feel of different markets, if you're traveling, plan ahead, things like that. We can just sort of drop it here. If there is, you'll notice up here, if the geolocator API can pull a place name from the coordinates, it'll put it up here. If not, it'll just show, I think rounded to the 5th digit, the latitude and longitude. That seemed to be the best way to do it. But so you get, I think we're in Iowa here. And also, by the way, I think at least a couple of people have been curious. I liked, this was just me, as far as centering. So the center zoom icon, you probably notice it doesn't center right on your location. This was just me. I preferred it centering to like the bounds of, what includes all of the stations on the dial. So that's what I have it, that are in your, the list of stations you got back. So that's what I have as far as if you hit this green little icon here, that centers it. So I think there might have been some question on that. Now I'll get into the coverage overlays in a second. Those now should center on the transmitter of the station. But as far as like when you're doing a location search, the little zoom button here, it just gives you the area-wide look at all of the stations that are on your search. So hopefully that might clarify it. But I thought this was pretty cool. And again, the same features work from here. So if you just wanted to limit it to medium stations, you can do that. And we'll get into, I guess next, I could probably get into, well, I'll do the coverage overlay next. So this is another trip thing from Rabbit Ears. So as part of this app, I definitely had thought, how to do coverage maps, but I figured, that could be a year, 2 years, 3 years down the road as far as trying to produce something that maybe took in the data that we're sending as far as the lists and putting them into a coverage map form. As it turned out, on Rabbit Ears, he has these Longley Rice coverage maps already set out for the TV side of things for sure, but he had been making some for FM as well, and just not, publicly available. And he was kind enough to allow them to be used on this project. And so, if we go here, all right, no, it actually, I think this. So just a random example here. But now I would say maybe about 75% of the US stations, I could be a little high on that. I think you'll probably find like Western booster stations or Western translator stations are not, they don't have coverage overlays for, but many of them do. And so they, reflect Longley Rice as far as the station's coverage area, kind of looking like a goldfish here, I would say. But so the one disclaimer I do have in here is the predictions on the the station side of things from the app that you're getting as far as KRJB here. Maybe I think what tends to happen, so the predictions in the app run at a different propagation curve than the actual maps are. So the maps are F5090, RadioLand's projections are F5050. And I think what ends up happening are the maps are a little less enthusiastic about the signal predictions versus the list. I could probably, if I dug around, show you some examples of that. But so that is, it's not one-to-one, I guess I would say, as far as a correlation between the signal strengths on the map and as far as the overlay and actually what's in the list. It could be, maybe 2 or 3 dBu VM off. So just something to keep in mind. I'm just thrilled to have them in the app, and I think they overall associate with what you're seeing, but it's not an exact match, I guess would be the one disclaimer that I would throw in there. So, but they're available for many, many stations. And I think they do a good job showing, particularly, in spots where there are differences in elevation, sometimes like the fringe areas. If we go back closer to home for me anyway, I think I can show you a couple examples of that. I'll use WLEV here. So you can kind of see maybe the reverse effect here, and this is real. I was going to do a section, we'll see if we have time, of examples where I think that Longley Rice really does well. One of the examples is, I would say right in my backyard. because so these signals from like the Lehigh Valley, where I could probably get you an exact height above ground level, they're fairly high up, at least relative to the rest of the area, and particularly down this way. And so, areas out here in the South Jersey Pine Barrens with just a little bit of elevation, we're talking maybe about 70, 80 feet above sea level. These Lehigh Valley signals, like really, there's nothing in the way. It's just, it's all sort of downhill. The fall line is about here. And so beyond that, if you get any little bit of elevation and even just even on, I guess, even terrain, like those signals get out really well heading southeast. I think anybody who has traversed around here, and I can say myself from living right about here, other than the fact that there is co-channel interference, because there's now a translator on 100.7 here in Philly. There's Wildwood ZXL. Again, the different scenarios that we're not necessarily factoring in, but still, like, the signal is legit. So I guess what I'm saying is, these maps and Longley Rice in general does a really good job. Whereas if you were just extrapolating the contour, which is again just the service area of the station, I guess what would probably be like the 48 dB contour, or I think I could probably, I could pull up Radio Locator, but it would probably,